Okay, so today we're going over two labs, both Lab 10 and Lab 11. I'm actually going to cover Lab 11 first because it's quicker, and then we'll do Lab 10. So, you take a look at the lab in Lab 10. This one is, or Lab 11. Thanks. This one is mass properties. And this one is going to be really quick. Basically, what Lab 11 talks about mass properties is that you can, in NX, you can pull up, if you assign materials to parts, you can then find out mass properties about that part. So to show that, what we're going to do is 11 assembly. Okay, so we have you should probably use your own subassembly that you made in Lab 4. If you don't have a complete copy of that, then go ahead and use the one that we put on the website. But we prefer you use your own for this. And so what you can do is, it should be parametric, like this model here, for example, that I made. I included a parameter called thickness lower control arm, which is the thickness of these beams. So I can change this parameter and it will update the model like so, right? Something simple like that. And there's other ones you should probably have length and width. And so what we're going to do here is we're going to find out what the mass properties of this are. So an easy way to do that, if we go to Tools, Material Properties, so we will define materials and assign them to objects. So we did this in the last lab, something very similar to this. So if I select this body and I say it's made out of ABS, for example, we hit apply. Now this volume, this solid, has the property of ABS. So all you have to do, this is really simple, like 3 clicks. Analysis. So we have to be in advanced simulation, I believe. Yes, so once we're in advanced simulation, analysis, advanced mass properties, advanced weight management. And you say, I want to calculate it on the work part, and then it gives you this information. So, the units are in kilograms, millimeters, so the density therefore is very small. It's this many kilograms per millimeter cubed. And so it'll give me the area of everything in the work part here, the volume of it, and then the mass. And it also gives you the location of the center of mass, moments of inertia, and a lot of other information, which is pretty cool. So the point of the lab is learn how to do this, pull up information that NX calculates for you about mass properties, and show that if you change some things about your model, that it will update. So in this one we had, just looking at the mass, for example, was 0.00514, right? And if I, let's see, let's go back to modeling. Actually, I should be able to. So if we just make this, instead of 3, we'll make it put it back to 5. And then we can check analysis, advanced mass properties, advanced weight management. Work part. So now we see the mass has increased to 0.00196. So that's Lab 11 basically. It asks you to open the lower control arm, this green one, right? Assign the material like we did, conduct a basic mass property analysis, and then adjust some of the parametrics and rerun the mass properties with the same material to show the improvements were made. So you can show that there's been a change in the mass properties. And then an improvement is a reduction in weight, reduction in moment of inertia, so it doesn't take as much energy to move and whatnot. So, and then it also asks to capture before and after image of the part, put them in a Google Doc, and a little bit of discussion of what improvements were made. And yeah, and that's basically it. And then it asks you to do the same with the entire assembly, and assign materials. So maybe ABS or plastic, maybe a steel pin and whatnot, and do a similar thing on an assembly level. That's basically it. And then it just mentions doing that with other parts down here. Are there any questions about Lab 11?
Just not really a question, but in the PDF on the website, it calls it front suspension assembly.
Right. Yeah, the same thing. So whichever yours is. So anyway, all right. Are there any other questions or comments? Okay, great. We're going to move to Lab 10 then.
Could you mention, for the sake of recording, that the name has changed?
Yes, the name on the website did change. In the lab on the website, it's called Front Arm Assembly, but it's this one that you did in Lab 4. Or if you need another copy, there's a simple version on the website of this same model or similar model. Okay, so Lab 10. Last week we worked on finite element analysis in NX using NX Nastran, and so today we'll be doing the same finite element analysis but on an assembly scale. So we're going to do a real simple model, this wheel with a shaft, and we'll be doing a few things, and then at the end we want you to do it on your lower control arm. So I'll be going through the tutorial that is on the website. All right. Yes, but first Jared's going to talk about different connections. You want to just go ahead and explain this, is because there wasn't a lot of lecture yesterday.
Okay, essentially this is what Dr. Jensen would have covered in lecture on Tuesday. Now, in meshing one part, you don't have to worry about connections. You just constrain it and put loads on it, and you're good. However, in this one, you have multiple parts. So you have to associate the interface, associate the two parts through some type of interface. In NX, there are three ways to do that. There's a surface-to-surface contact, a gluing contact, and then 1D rigids. The surface-to-surface one, that one really only works if you have a shared surface between the two meshes. But it allows you to, it requires you to have all your nodes line up and everything just like in hypermesh. Some of you probably had the problem where your parts flew away because the two meshes weren't perfectly connected. You'll have the same problem in NX if the two parts, their meshes aren't connected. The other option is called gluing. That one, you don't have to have the parts actually touching. They have to be pretty close, but you don't, and your meshes don't have to line up. It's an option that essentially makes lots of little connections from node to node, even if they're separated or skewed a little bit. That will pass stress from one part into the other part. Eric will show you how to use that button, what the button looks like in the tutorial. That one is nice because essentially you don't have any discontinuities in stress from one part to the other. The last one is what's called a 1D rigid. It's a lot like what we used in hypermesh for connecting constraints to the rest of the part. In NX Nastran, it's commonly used for bolts or pins or a centralized load, much like hypermesh. Those three are really the three ways to connect things together. Generally, you'll be using gluing or the 1D loads. 1D rigids. Does anybody have any questions about that? Cool. Yeah, Eric will show you a little bit more about those.
All right. Excellent. Okay, so the part that I've opened, this is the first page of the tutorial already, is the wheel shaft assembly. And it asks us to, so make sure you're in full with advanced menus, which will give you all the buttons. We're going to go to advanced simulation so that we can do the FEA. It asks us to go to preferences, user interface, and reset dialog box settings. And, all right, so in the simulation navigator, simulation file view, it says that we should say new FEM. And it asks us to call it wheel FEM1. Okay. And on the new part, we just need to make sure it is NX NAS transstructural. Hit OK. And same thing on this next one. It doesn't pop up. Never mind. It has a save. So if you want to save, you can click save there. So now, in the simulation navigator, on wheel FEM1, we can right-click and say New Mesh 3D Tetrahedral. So this is the same thing as just clicking this button here to make a new mesh, but we'll do it this way. All right, so it wants us to select first the pin, and for element size, if we click this button right here, it will find an automatic element size, which is a good mesh size for this part. So it says 13.5 is good, so we're going to hit apply, and it will mesh it. And then we're going to also mesh this part, and we say automatic again. And now it says for this, an ideal element size is 15.6. And we'll click OK. All right, now in the system navigator, if we expand 3D collectors, so we have this one, which is that mesh there, and then this mesh here. And it has us change the color of solid 2, which is the wheel. So if we right click on solid 2 and say edit display, then it has this color, and it says to do some kind of green. Really, you can pick whatever. I'll just pick this one. And okay, and now it changed the color of that mesh so that you can tell different parts. You can separate them and see which parts are which. That's quite useful when you have a large assembly of meshed parts. Okay, now we're going to assign a material property. So under 3D collectors solid 1, if we right click and say edit, and then under solid property here, if we go to modify selected, which is what it asks for, and choose material, if we click the button here, and it asks us to make this one steel. So, steel. Okay. And okay. And okay. So now this pin, which is this solid here, has the material steel, and it wants us to assign nylon to this solid 2. So edit, we go to solid property, material, and nylon. Okay. I will check that, yeah. Solid 1, which is this guy. No, he's steel. Okay. All right. Now we're going to create the simulation file. So on simulation file view, on wheel FEM1, we right click and say new simulation. And it wants us to name this one wheel sim1. All right. And we click, make sure this is NX NAS transstructural. Okay. And it tells us under this single constraint, if we go to case control. Okay, so this part in the lab is kind of specific. So just go real slow and make sure you can find everything. So it tells us to go to the case control tab and then create modeling object under, under global contact parameters here. So if you click create modeling object, and it wants us to change the contact changes for convergence. Instead, we want to change that to number of contact changes. That brings up this new line right here, allowable number for contact changes. We want that to be 20. And then also contact status, start from pre